A very good morning to our dear Dr. Arun Gupta. Today, we are from Group 5 and we will be presenting the topic molecular diffusion through three mediums, gas, liquid and solid. So let me introduce to you my group members, which are GUNAVAATHY, SHUSHMITA, DHARSHINI Devi and myself. Let's start with the first one, a brief introduction on mass transfer process. So mass transfer is the net movement of mass from one location to another or travel of individual chemical species from high concentration region to low concentration regions. There are a few examples of mass transfer process. Those are evaporation of water from a pond to the atmosphere, the distillation of alcohol, and the purification of blood in kidneys. So the next is the introduction of Fick's law for molecular diffusion. Molecular diffusion or molecular transport can be defined as the transfer or movement of individual molecules through a fluid by means of random individual movements of the molecules. We can imagine the molecules traveling only in straight lines and changing the direction by bouncing off other molecules after collision. Since the molecules travel in a random path, molecular diffusion is often called random work process. A random path that molecule A might take in diffusing through B molecules from point 1 to point 2 is shown in this figure. The schematic diagram of molecules diffusion process. So the next part, introduction of molecular diffusion. Diffusion explains the net flux of molecules from a region of higher concentration to one of lower concentration. Once the concentrations are equal to the molecules continue to move, but since there is no gradient, the process of molecular diffusion is known as self-diffusion. As an example, the experiment starts by placing a sample of the dye in a thin layer halfway down the tube. Diffusion occurs because all molecules move due to their thermal or heat energy. This means that there is a net movement of dye molecules from the high concentration region to the low concentration region. So now my team member SHUSHMITA will continue.
Hi everyone, I am SHUSHMITA KARTHIGESU. I will explain about molecular diffusion in solid. The rates of diffusion of gases, liquids and solids in solids are generally slower than rates in liquid and gases. Mass transfer in solid is quite important in chemical and biological processing. Some examples are leaching of foods such as soybeans and metal ores, drying of timber, salts and food, diffusion and catalytic reaction in solid catalyst. Transport in solids are divided into two types of diffusion, where diffusion that can be considered to follow Fick's law and does not depend on the actual structure of the solid, and diffusion in porous solid, where the actual structure and void channels are important. Next slide. Molecular diffusion in liquid. Diffusion of solutes in liquid is very important in separation operations such as liquid-liquid extraction or solvent extraction. Diffusion in liquids also occurs in many situations in nature such as oxygenation of rivers by the air and diffusion of salts in blood. The molecules in a liquid are very close together compared to a gas. Thus, the attraction forces between the molecules are much stronger than in the gaseous phase. The concentration in liquids are considered as higher than in gases. For diffusion through stagnant, the diffusion is between diffusion of ethanol through water. The equation can be used to calculate the rate of diffusion between the ethanol through water. Next slide. Molecular diffusion in gas. Molecular diffusion in gas is transport of material in stagnant fluid or across streamlines of a fluid in a laminar flow that occurs by a molecular diffusion. Two adjacent compartments separated by a partition containing pure gases A or B. Random movement of all molecules occurs so that after a period molecules are found remote from their original positions. If the partition is removed, molecules of A move towards the region occupied by B. Their number depends on the number of molecules at the region considered. A complete mixing occurs. That's all from me. My friend Darshini Devi will explain more. Thank you.
Hello everyone and good day to Dr. Arun Gupta. So now I'm going to show you all the flow diagram of M file. So the program will start with start, and then a menu bar will appear in the screen, and then if you want to continue with the case 1, you can enter the case 1, and then we'll continue to the user defined function. Then after a plotting will again for the condition for case 2 end. So next is about the flow diagram of guide user interface. So the program will start with start, and then next we need to input the value for distance, next input value for temperature, next input value for partial pressure at point B, next input value for partial pressure at point B, and next input value for diffusivity. Next, for the click the calculate button to display the value for steady flux. Next, click plot button to generate a graph for the next, click reset button to insert the another value, and finally the program will end. So that's all from me. Next, my team member will continue.
Hi everyone, I'm GUNAVAATHY SARAVANAN. Now we are going to look at the results which we obtained from the menu button. So for the first case, we have diffusion of ammonia gas through nitrogen gas against the distance. So we need to input the value of partial pressure at point A, value of partial pressure at point B, and the range of distance. So then only we can get the graph. So for the second case, we have diffusion of water vapor through non-diffusing air against the distance. So for same like first case, we need to include the partial pressure and the range of distance. Then only we can get the graph. And for the third case, we have diffusion of acetone through water against the distance. So same goes like case 1 and case 2. So the next case will be diffusion of ethanol through water against the distance. So we need to include concentration for this case, for concentration of ethanol and concentration of water at point A and point B. So for the next case, we have diffusion in biological gel, which is bind against the distance. And for the last case, we have diffusion in biological gel, which is free against the distance. So now I'm going to show you, going to run the program to show you how to obtain the graph. So this is the coding part our group do for the menu button, and now I'm going to run the program. And after run the program, we will get the menu button, which will show the 6 cases. And for example, I'm going to show you the first case. And for the first case, we need to include the partial pressure at point 1, which is And for the range, after input all the values, we are getting the graph, which is this one. So same goes for the other cases. We need to include the input, then we can get the graph. So that's all from me. Now my friend going to explain the GUI.
Hello everyone again now I'm going to explain you all about the steps to obtain the result from guide user interface program. First step, after the program ran, the following GUI will appear. Next step, all the values for the variables enter except for the steady flux. Then click the calculate button, click to calculate the steady flux. The value for steady flux will show up. Next step, next pop-up menu, click to choose between which graph to appear. Plot button clicked and the a graph of diffusion rate versus distance will appear. And the last step, so this is the coding for the GUI. So now I'm going to run the coding part. So this the GUI will appear in your screen. So next step, we need to insert the value for distance, temperature, partial pressure at point B, partial pressure at point A, point B, and diffusivity. So let's start. First for the distance, 3.6, and for the temperature, 298, and for the partial pressure at point A, 121. Okay, next. Okay, now I'm going to click the calculate button to calculate the steady flux. So this is a value for steady flux. Next, we're going to click the pop-up menu to choose between the plot distance or the bar graph. So now we're going to choose the plot. So click the plot button. So here you go, the graph for the diffusion rate. Again, for the pop-up menu, we're going to choose bar graph and then plot again. So this is the bar graph for the diffusion rate. So finally, if you want to continue with the another values for the distance, temperature, partial pressure, so you have to click the reset button. So the values all will be 0 and you can insert the values again. So that's all from me. Thank you.